The Antonio Project presents Chapter 3 PVT Diagram and Steam Table. Hello everyone, welcome back to my channel. This is Chapter 3 of Steam series. In this video, we will explore two essential topics in steam engineering and power plant operation: the pressure, volume, temperature or PVT diagram of water and how to read steam tables. The PVT diagram helps us visualize how water changes between the solid, liquid, and vapor phases under different pressures and temperatures. It allows us to understand important regions such as the compressed liquid region, the saturated liquid vapor mixture region, and the superheated steam region. Once we understand where a state lies on the PVT diagram, we can use steam tables to determine the exact thermodynamic properties of water and steam, including specific volume, internal energy, enthalpy, and entropy. Learning to read steam tables correctly is a fundamental skill for engineers working with boilers, steam turbines, refrigeration system, and many other thermal processes. So, let's get started and dive into the fascinating world of water, steam, and thermodynamics. Let's go! Pressure, volume, temperature, or PVT diagram. We will discuss the PVT diagram for water, also known as the PVT surface. I will create a 3D PVT diagram of water by gathering available information such as from Wikipedia, biomodel.ueh.es etc. based on the 1995 EAWPS formulation for water. Water's behavior is a rare exception to the standard physical rule governing phase change for the vast majority of materials. Water is one of the simple substances that expand upon freezing. From the two-dimensional PT, TV, and PV graphs, a PVT diagram can be constructed. Since those 2D diagrams is obtained by projecting the base boundaries of the PVT surface onto the plane. The pressure, temperature, or PT diagram, also known as the phase diagram, plots pressure against temperature and is especially useful for understanding phase transitions and the conditions under which different phases exist. The PT diagram reveals several important characteristics. Sublimation curve, the line separating solid and vapor phases, representing the condition for sublimation and depositions. Vaporization curve, the line separating liquid and vapor phases, representing the conditions for boiling and condensations. Fusion curve, the line separating solid and liquid phases, representing the conditions for melting and freezing. After create the lines by copying the lines from the PT graph, this is the result of projection the lines on the 3D graph. And the line is then projected to TV graph and PV graph. The temperature specific volume or TV diagram is a graphical way of representing relationship between temperatures against specific volume. This projection is particularly useful for understanding processes that occur at constant pressure, as isobars or line of constant pressure appear as curves on this diagram. The pressure-specific volume or PV diagram is one of the most frequently used projections in engineering thermodynamics. It plots pressure against specific volume at constant temperature and clearly shows the vapor dome, which represents the boundary between liquid and vapor phases. The merge of these three graphs will form a 3D PVT diagram. The pressure, volume, temperature or PVT diagram of water is a three-dimensional thermodynamic representation that shows the relationship between pressure or P, specific volume or V, and temperature or T for water and steam. It is one of the most important tools in thermodynamics and steam engineering because it illustrates how water changes space under different conditions of pressure and temperature. Water exists in three primary phases: solid or ice, liquid water, and vapor or steam. The PVT diagram combines all possible equilibrium states of these phases into a single surface known as the thermodynamic surface. Every point on the surface represents a unique state of water characterized by a specific pressure, temperature, and volume. The PVT diagram is especially valuable in the design and operation of boilers, steam turbines, condensers, and other thermal power plant equipment. Engineers use PVT diagram to understand phase transitions, determine thermodynamic properties, and analyze energy conversion processes. Following is the features of PVT diagram. Liquid region, the area between the fusion and vaporization curves, where the substance exists entirely as a liquid. Solid region, the area below the fusion and sublimation curves, where the substance exists entirely as a solid. Vapor region, the area below the vaporization and sublimation curves, where the substance exists entirely as a vapor. Triple point, the unique point where all three phases, solid, liquid, and vapor, can coexist in equilibrium. For water, the triple point occurs at temperature of 273.16 Kelvin or 0.01 degrees Celsius or 32.0.18 degrees Fahrenheit and a pressure of 611.7 Pascal or 0.00611 bar. Triple line, a line rather than a point as in 2D projections, where all three phases can coexist. Saturated liquid line or VF, the left boundary of the vapor dome, representing states where the substance is entirely liquid, but at the point of vaporization. Saturated vapor line, the right boundary of the vapor dome, representing states where the substance is entirely vapor, but at the point of condensation. Liquid vapor region or liquid vapor dome, surfaces where liquid and vapor phases coexist in equilibrium, with the relative amounts of each phase determined by the specific location on the surface. Critical point, the point at the top of the liquid vapor dome where the properties of saturated liquid and saturated vapor become identical. The critical point of water occurs at 647.1 Kelvin or 373.9 degrees Celsius or 705.1 degrees Fahrenheit with pressure of 22.1 megapascal or 220.6 bar and with specific volume approximately 0.0036 cubic meter per kilogram. Solid vapor region represent the areas where solid vapor distinct phases coexist at equilibrium. Solid-liquid region represent the areas where solid-liquid distinct phases coexist at equilibrium. Gas region exists at temperature above the critical temperature. No distinct liquid-vapor boundary exists in this region. In a PVT surface of water, the terms vapor and gas are often used interchangeably in everyday language, but thermodynamically they have different meanings. Vapor region exists at temperatures below the critical temperature, 374 degrees Celsius for water. Can be converted to liquid by compression alone at constant temperature, located between the saturated vapor line and the critical point. Example, superheated steam at 200 degrees Celsius and 1 bar. In steam engineering, superheated steam is considered a vapor. Gas region exists at temperatures above the critical temperature, cannot be liquefied by compression alone. Cooling below the critical temperature is also required, located beyond the critical point. Example, water at 450 degrees Celsius and 250 bar, or supercritical region. How to read steam table? The PVT diagram and the steam tables are closely related because steam tables provide the numerical property data for the states represented on the PVT diagram. A steam table is a reference table used in thermodynamics to find properties of water or steam, such as temperature or T, pressure or P, specific volume or V, internal energy or U, enthalpy or H, entropy or S. Types of steam tables. 1. Saturated water temperature table contain thermodynamic properties of saturated water and steam arranged according to temperature. 2. Saturated water pressure table contain thermodynamic properties of saturated water and steam arranged according to pressure. The saturated water table represents the area of liquid vapor dome. The saturated liquid volume, or Vf, represents the specific volume, or V, and fluid F lie on the saturated water line. The saturated vapor volume, or Vg, represents the specific volume, or V, and gas, or G, lie on the saturated vapor line. Three, superheated water table. A superheated water or steam table gives the thermodynamic properties of steam when it has been heated to a temperature above the saturation temperature corresponding to its pressure. Four, compressed liquid water table, also called a subcooled water table, gives the thermodynamic properties of water when it exists as a liquid at a temperature below its saturation temperature at a given pressure. Five, saturated ice water vapor table. A saturated ice water vapor table provides the thermodynamics properties of water at equilibrium between ice or solid water and water vapor. This is how to read steam table in connection with PVT diagram. For example, if the known temperature is 100 degrees Celsius, If we draw a straight line, the pressure is 101.42 kilopascal. The line intersects the saturated liquid line with a value of 0.001043 cubic meter per kilograms and the saturated vapor line with a value of 1.672 cubic meter per kilogram. The other value correspond to the green box in the table. The next known temperature is 0.01 degrees Celsius. In the same way as before, we can find the values of specific volume, internal energy, enthalpy, and entropy. The known temperature value is 60 degrees Celsius. The value in the table is in the green box. The known temperature value is 300 degrees Celsius. The value in the table is in the green box. For the superheated, subcooled, and saturated water vapor tables, it may be necessary to use interpolation to find the correct values. We have now reached to the end of this discussion on the PVT diagram and how to read steam tables. Today, we learned that the PVT diagram provides a visual understanding of how water changes between its different phases under varying pressures and temperatures. We also saw how the diagram helps us identify important regions. More importantly, we learned how to use steam tables to obtain the thermodynamic properties of water and steam, including specific volume, internal energy, enthalpy, and entropy. By determining the state of water first and then selecting the appropriate steam tables, we can accurately analyze and solve thermodynamic problems. Thank you for watching. I hope this video has made the PVT diagram and steam tables easier to understand. If you found this video helpful, please like, share, and subscribe for more content on steam and marine engineering. Until next time, keep learning, stay curious, and see you in the next video. Bye-bye. Enhance your knowledge by subscribing to our educational content. Subscriptions are free and it's fueling to our channel. Thank you for your kind support. Your subscription will definitely keep our engine running smoothly.
Thank you for watching my video. Terima kasih. I Antonio Project.